Let's look at this question. In the company outing of Audi Incorporated, exactly 4 events, events 1 to event 4, were conducted for employees of the company. The total number of employees in the company was 150, and each employee participated in at least one event. So all the 150 employees have participated in at least one event. The following information is known about the number of employees who participated in each event. For n equal to 1, 2, 3, 4, any employee who participated in event n participated in at most one of event n-1 and event n plus 1, provided the event exists but not in any other event. This is an extremely important instruction, because what this means is, let's say you've participated in event 1, then you can also potentially participate in event 2, but you cannot participate in anything else. Similarly, if you participated in event 2, then you can potentially participate in event 1, you can potentially participate in event 3, but not both. Everyone is either participating in one event or two events. Everyone is participating in one event or two events. Representation wise, a simple way to show it would be this: event 1, event 2, event 3, and event 4. Can you see that event 1 and event 3 will not have any overlap? Event 3 and event 4 will not have any overlap. Sorry, event 1 and event 4 will not have any overlap. Event 2 and event 4 will not have any overlap. The only possible places of overlap are 1 and 2, 2 and 3, and 3 and 4. These are the only possible places where a person is participating in multiple events. Okay. The number of employees who participated in event 1 is 10 more than in event 4, which in turn is 15 less than those who participated in event 2. So I'm saying, if this is X, if the number of participants in event 4 is X, number of participants in event 2 is X plus 15, and number of participants in event 1 is X plus 10. The number of employees who participated in event 1 is 10 more than that in event 4, which in turn is 15 less than those who participated in event 2. This is also taken care of. The number of persons who participated in both event 2 and 3 is same as the number of number of persons who participated in both event 1 and 3. Now, this is an awesome piece of information. This is an awesome piece of information because, remember, event 1 fellow could only participate in at most event 2. So when they're saying event 1 and event 3, whatever is the overlap of event 1 and event 3, this is definitely 0. So the number of people who participated in event 2 and event 3 is also equal to 0. So this portion is definitely 0. And the number of persons participating in both event 3 and event 4, this portion is also 0. Okay. Next, exactly 25 persons participated in event 3. In event 3, the only region left is this. So exactly 25 persons participated in event 3, while exactly 50 employees participated in more than one event. The only possible pair of events where people can participate in more than one event is event 1 and event 2. You have 50 people here. You have 50 people here. Okay. Now see, we know that number of people who participated in exactly one event. Let those people who participated in exactly one event be A. Those who participated in exactly one event, and those who participated in exactly two events, let that be B. We know people who participated in exactly 2 is 50. In terms of number of people, I know A plus B should be equal to 150, or A is equal to 100. Total number of employees was 150. If 50 people have participated in exactly 2 events, 100 people have participated in exactly one event. Okay. So if 100 people have participated in exactly one event, can I also go on to say number of times? Sum of event 1 is X plus 10, event 2 is X plus 15, event 3 is 25, and event 4 is X. All of this should add up to give me 150 every person counted once, And these 50 people who are present in both event 1 and event 2 would have been counted twice, or this total would be equal to 150 plus 50 or 200, or I have 3x plus 50 is equal to 200, or x is equal to 50 itself, which means number of participants in event 4 are 50. They can only participate in event 4. Number of participants in event 2 are 65, and for event 1 there are 60, of which 50 are already accounted for. So you have 10 people here, you have 15 people here. All the people, the entire population has now been allocated some region. We can get to individual questions. How many employees participate in at least 2 events but did not participate in event 1? Okay, participated in at least 2 events. Only this group, E1, E2, but did not participate in event 1. So this 50 also we can't count. There are no employees who participated in at least 2 events but did not participate in event 1. So the answer to the first question is 0. Next question, how many employees participated in event 4 and at most one other event? Event 4 and at most one other event, 0 plus 50. There are 50 such people. Which event did the highest number of employees participate in? In which event did the highest number of employees participate? Event 2, 65 participants we had. So option B. And last, among the employees who participated in exactly one event, how many employees participated in either event 2 or event 3? Either event 2 or event 3. 15 plus 25. There are 40 such participants, or the correct answer will be option C. And that is the entirety of this set. This set entirely depends on you being able to correctly interpret this point, understand this point. After that, representation becomes easier to manage.